This video shows how to use the binomial theorem to expand a binomial raised to a positive power. So we're going to write the binomial expansion for this binomial 2x minus 3y raised to the fifth power. Originally I was going to do it to the seventh, but that's just too many terms, so I just decided to do 5. So what you do is each term, and there's always going to be one more term than there is this power. So there's this power is 5, so that means there's going to be 6 terms. What you're going to see is each term will have a coefficient, and the coefficient is going to have 2 numbers here, and it's going to be n choose r. This is the same thing as a combination n choose r, and this is defined to be n factorial over r factorial times n minus r factorial. So for instance, if you had 5 choose 2, this is equal to 5 factorial over 2 factorial times 5 minus 2 factorial, which would be 5 times 4 times 3 times 2 times 1 over 2 times 1, that's 2 factorial. 5 minus 2 is 3, so this would be times 3 factorial, 3 times 2 times 1. And so 3 times 2 times 1 divides into 3 times 2 times 1. 2 goes into 4 twice. 5 times 2 is 10. You have 10 over 1 or just 10. So that would give you a 10. So what you're going to see each term of this expansion will have a coefficient in the front. And you'll see me write numbers in this. And what this means is n choose r, and that's how it's going to be defined. So the first term to get this going is this is going to be a coefficient, the coefficient n choose r, and then it's going to be the first term raised to a power times the second term raised to a power. And so the first term of this binomial expansion is 2x. 2x will go here, and negative 3y will go there, and then I'm going to put numbers in here to figure out the coefficient. So we're going to also put powers right here on each term. So to get ready for this, here's going to be where I put the coefficient, which is a combination. Then it's going to be 2x. I'm going to sneeze, raised to a power, and then it's going to be negative 3y raised to a power. I didn't sneeze. Plus the third term, the coefficient, times 2x raised to a power times negative 3y raised to a power, plus the coefficient, 2x raised to a power, negative 3y raised to a power. Let's see. 1, 2, 3, 4. I need 2 more places. The coefficient, the first term, 2x raised to a power, negative 3y raised to a power, plus the last term, 2x raised to a power, negative 3y raised to a power. Let's see. 1, 2, 3, 4, 5, 6. Okay, I've planned for all those. Now what goes in here are the 2 numbers that we're going to take the combination of. N is equal to the power. So 5 goes in the top one of every one of these combinations. And then down here, the bottom number counts up. So it goes 5, and then we start with 0. 5 choose 0, and then 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. And you know you're done when you have the same number here on the top and the bottom. What's going to happen, we have to raise each of these terms to a power. The bottom number here in this combination is the same thing as the power of the second term. So that's being raised to the 0 power. This is being raised to the first, the second, the third, the fourth, and the fifth. And what's happening with the first term is it's being raised to the highest power, 5. It'll be the same as this starting, and then as it goes down, it's going to count down. So this went from 5 to 4 to 3 to 2 to 1 to 0. So what you'll notice is that the first term of the binomial that you're expanding, 2x, its power goes from the highest, 5, to 4 to 3 to 2 to 1 to 0. It counts down to 0. While the second term of the binomial, negative 3y, starts from 0 and then it counts up by ones, 1, 2, 3, 4, 5, until it gets to n, which is 5. Now, I'm going to use my calculator to help me get these combinations because I don't want to do this a million times. It'll take a long time. So I can do 5 choose 2 in my calculator. And 5 choose 0 is I said 5 choose 2. 5 choose 0 is always going to be 1. But I'll show you in my calculator how you can do it as well. Hang on just a second. Okay, so let us... I'm going to go ahead and figure out the coefficients. I'm going to do 5 choose 0. So on my calculator, I enter 5, and then I hit math button, and then I toggle across to PRB, which stands for probability, and I'm going to select 3, which is the C, the combination function. And then I enter the 0, 5 choose 0, and that tells me that it's 1. This is a 1. I'm going to go ahead and do it for all these while I'm here. 5, math, go to probability, hit enter. Oops, I hit the wrong thing. 5, math, go to probability. I want to hit 3, and then choose. Oh, that was 5 choose 0, 5 choose 1, and that gives me that this coefficient is a 5. I'm going to do 5, math, probability 3, choose 2. That gives me, this one's going to be 10. And 5... math, probability 3, choose 3. That gives me 10. And this is Pascal's triangle, and it is symmetric. So this term is going to be 5, and this term is going to be 1. And if you weren't sure, you could go through the same thing. You could either hand calculate it using this or continue to use your calculator to find the terms. And this is going to be 2x raised to the 5th power, which is 2 to the 5th power, which is a 32, x to the 5th power. And then negative 3 to the 0 is a 1, plus. The coefficient is 5. 2 to the 4th power is 16. X to the 4th power is x to the 4th, times negative 3y to the 1st power is negative 3y. Plus, the coefficient is 10. 2 to the 3rd power is 8. X to the 3rd power is x cubed. Negative 3 squared is negative 3 times negative 3, which is a 9, y squared, plus the coefficient is 10. 2 squared is 4, x squared is x squared. Negative 3 raised to the 3rd power is negative 27, y to the 3rd, plus coefficient is 5 times 2x times negative 3 to the 4th is positive 81, y to the 4th. Plus 5 choose 5 is 1, 2x raised to the 0 power is 1, and negative 3 raised to the 5th power, with the help of my calculator, is negative 243 y to the 5th. Now, I'm going to go through and multiply things together. 1 times 32 times x to the 5th is 32x to the 5th, times 1 is 32x to the 5th, plus 5 times 16 times negative 3 is negative, oops, this is going to be minus 240 x to the 4th y. And then 10 times 8 times 9 is going to be 720 x to the 3rd y squared. And then 10 times 4 times 27 times negative 27 is going to be negative 1080 x squared y to the 3rd. And then 5 times 2 times 81 is going to be 810 x y to the 4th. And then 1 times negative 243 is negative 243 y to the 5th. So this right here is the binomial expansion for 2x minus 3y raised to the 5th power. All right, you can also do something else. You could just find a term in the middle of a binomial expansion if you wanted to. Write the 13th term of the binomial expansion for this binomial 5x plus 7y raised to the 20th power. So in this case, n is 20. Well, let's just observe the pattern here. This right here created the first term. If we notice the first term, the top number of my combination is 5, and the bottom number is 1 less than the term. For instance, here's the second term. This is the second term, but the bottom number is 1. So if we look at that pattern, for the 13th term, the bottom number is not going to be 13, it's going to be 12. And N20 is the top number that goes right there. The first term, 5x, will be raised to a power. The second term, 7y, will be raised to a power. The power that the second term is raised to is 12. The power that the first term is raised to is whatever I can add 12 to get 20. Whatever I can add this to get 20. Because if you'll look again up here at this, 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. These powers always add up to be n. So 12 plus what would give me 28. So I'm going to use my calculator right here. I'm going to say 20, choose, I go to probability, I hit 3, 20, choose 12, and that gives me a huge number, 125970. This is 125970. 5 to the 8th power is 390,625. X to the 8th. 7 to the 12th power is too big for my calculator to really spit it all out. It's 1.38 times 10 to the 10th. 1.38 times 10 to the 10th. Y to the 12th. And these are so big, my calculator is just going to have a lot of trouble. I'm going to leave this as my 13th term.